Hi, once again, good morning, everybody. I would like to welcome you all to our webinar, Accelerate ROI on Your Data Lake Investment. Let me first start by introducing the panelists and the speakers. So my name is Krishnan Parasuraman. I head the Sales and Business Development function at Splice Machine. Really looking forward to this webinar and sharing some of my personal experiences on data lakes and operationalizing data lakes with all of you. With me, I have Brent Snyder from Sonoco. Brent is the senior data architect at Sonoco, and he will be sharing some of his perspectives on his journey towards building a data lake. Brent? And then we also have Ravindra Punuru from Diyotta. Ravi is the Chief Technology Officer at Diyotta.
Hello, everyone. Good morning and good afternoon.
Yeah, so let's get started. So just as a matter of order, we will be recording this webinar, and within 48 hours, all the attendees would be getting a link with the recording of the webinar and the slides that have been used in this. Our presentation and discussion will probably take about 30 to 40 minutes, and then we'll have time in the end for Q&A. You can use the chat functionality within Zoom to post your questions. We'll be answering them as we go through this, or we could take them at the end. Okay, so that's how we'll engage with you. So the topic of our webinar today is accelerating ROI on your data lake investment. Now, some of you may have already made investments in your data lake and may already have one in place. And I would also understand that some of you are in a stage where you're just starting out, right? You may be in the process of just building your data lake or maybe thinking about architectures. Regardless of what stage you are in, we believe that today's webinar would be immensely valuable to you. That's because between myself, Brent, and Ravindra, we have enormous amount of experience and learning in this space that we want to share with all of you. So building and managing data lakes used to be a very complex process. It used to be an extremely time-consuming and some may argue a very expensive process, but that's not the case anymore. We are advocating an architectural design pattern that would dramatically reduce your time to market, reduce your risks and costs associated with building and managing a data lake. And that's what we are going to show you today. So our goal is to show you how you can build a data lake in 15 minutes, from ingestion from multiple data sources to managing the different layers or zones in your data lake for consumption. And we'll show you how easy it is to set one up very quickly. Okay. So from an agenda perspective, I'll kick off the conversation with some of the challenges that we have seen with data lakes, what has been the promise and what is actually the reality. And then we'll look at some of the typical issues and why traditional approaches are failing for data lakes. And then we'll look at both Splice Machine and Diyotta's technologies as to how they address these challenges and gap. Brent from Sonoco will provide an industry practitioner's perspective on how he went through a traditional approach that wasn't successful and then ended up applying a more modern approach. And finally, Ravi will show you a demonstration of building a data lake using both Splice Machine and Diyotta. Okay, so just to set a little bit of context, I'm sure probably everybody here in this call or in this webinar is interested in this topic of data lake. And what's fascinating is the promise, right? So when we talk to customers that have built data lakes, and when we ask them what they wish to achieve, we generally get that their data lake is a means to an end, right? The end is to become an intelligent, AI-driven enterprise. They want to undergo some type of digital transformation and use data to power all of its decisions. And the data lake is the stepping stone or a means to achieve that. And they believe that the data lake will help them with the following use cases, right? First of all, by bringing all their enterprise data and disparate data sources in one place, they expect their data scientists to run analysis and find some compelling nuggets of intelligence, right? That has the potential to transform their business, right? And depending on the industry, this could be analysis and machine learning to detect fraudulent patterns in your data. Or if you're a consumer-focused business, it could be to create customer behavior models to predict what they're likely to buy. Or if you are in sort of a manufacturing space, these could be insights that help you determine your machinery status and when they're likely to fail, right? So that's one of the most common use cases. And then the other one is to build sophisticated and complex data pipelines, right? So pipelines that can help them act on real-time or streaming data, and also help them scale their processing or data processing in a way that was previously impossible, right? Another common use case that we hear a lot from our customers is they want to offload their data marts or expensive data warehouses into the data lake and drive a significant number of their reporting and batch workloads on the data lake. So this is a way for them to drive cost containment, right? So the benefits of the data lake typically fall into three categories. One is it helps them drive net new insights. The next is it could be a new scalable platform that can reduce their ETL or batch processing windows from 12 hours to somewhere like 3 or 4 hours, and it can process more data than before. Or it can be a solution that reduces their expensive MPP data warehouse footprint and provides better price performance on analytics, right? So it's a combination of these three benefits that we see that our customers are using to power their data lake. So this is the promise, but what's the actual reality, right? The reality is as organizations go through this process, they sort of encounter a lot of different challenges. A couple of them are, first of all, these projects take too long to deliver, right? So we've been talking to customers who have been at this for months, if not years, trying to get this right. And the reason why it can take too long is because, when they're trying to acquire data from different source systems, that process is cumbersome, right? Because it's new technology. Typically, when you use Hadoop or even AWS as your data lake environment, bringing data from different sources, structured, unstructured, and then getting them all in the right format, in the right place, can take time. The second challenge that we see is typically when organizations try to put together a data lake architecture, they end up duct taping multiple storage engines, multiple compute engines, and piecing them all together can be a daunting task, right? There is no easy button there. And then the other challenge is essentially once you have loaded your data or migrated your data one time, and then you want to apply incremental changes. You have changes on your source systems and you want to push that into the data lake. That can be very difficult because typically a Hadoop-based data lake doesn't necessarily process changes or incremental changes easily. You have to write custom code or you have to use specialized tools to achieve that, right? So these are some of the areas that customers of ours necessarily don't anticipate upfront, and as a result, you have their projects ending up taking too long. The other challenge is their end users or business users' expectations are not necessarily met, right? And part of the reason is because a data lake provides you multiple consumption paths for your data. So there's a lot of different tools, right? So you may, and I have customers of ours who say, hey, look, I have this data lake, I have data sitting there, but there's just 10 different ways to get to it, right? What's the right consumption path? If I'm running an application, it's very difficult. If I'm using a BI tool, it's not interactive. So there's just too many consumption paths, and that makes adoption a little hard. And then organizations that have gone ahead and built analytical data models, they're doing AI or machine learning, they find that very hard to operationalize in the data lake context, partly because it's very hard to build transactional applications that work seamlessly against the data lake, right? So these are some of the challenges that sort of drive, that hinder adoption, right? So just to sort of reinforce these points a little bit more graphically, there's two main issues or two or three main issues. One is this duct-taped architecture, right? So you may have a Hadoop-based data lake that has multiple nodes and you have data sitting on it. And then your use cases may be either to run like a BI tool on top of it using Click, Tableau, business objects, whatnot, or you may want to use some kind of sophisticated analytics. You may want to run some type of real-time processing or real-time decisioning. or streaming on top of this data lake, or you may even want to run some type of just transactional application, right? And today you have multiple paths and tools that are tied to those access mechanisms, right? So if you wanted to use BI tools, then you want to use like a Hive or an Impala type SQL Hadoop tool. If you're running something a little bit more sophisticated, like machine learning or analytics, then you have to use something like a Spark, right? If you are using some type of streaming technology or real-time applications, then you may end up using HBase or Phoenix or Kafka. And then again, if you have to run applications, you can do that, especially transactional applications can't run on this type of architecture. So you end up pushing the data out of your data lake into a traditional database like Oracle or SQL Server to power your applications, right? So as you can see, these are different pieces of technology that are duct taped together, and you have different types of consumption models that are fragmented, right? And this is what I was explaining a little earlier, are some of the challenges that make this process cumbersome, expensive, and the adoption rates are poor because of this, right? So architecturally, what makes sense is to simplify that consumption piece, right? So if you had a single engine that could run mixed workloads, be it OLTP and OLAP, right? Then what you could do is you can run your transactional applications or microservices directly against the data lake without having to offload this using an ORM or some other mechanism to an external database. And you could also run analytics directly. And then if the engine selection was automatic, right? So if you said, hey, here's a workload, here's a SQL query, right? Regardless of whether it was an analytic query, a transactional query, or a machine learning type workload, if the engine selection was automatic and what's not decided by developers, you can drive more seamless adoption across those developers and end users, right? Because all they're doing is you're just sending a query and the system automatically picks the right engine and works, right? And then if you can run transactional applications, you can start operationalizing some of your machine learning and analytic insights and push that directly into end user interfaces like web portals or applications and so on and so forth, right? So that's sort of the idea behind simplifying the architecture. In terms of tools, I want to introduce Splice Machine and talk about how Splice Machine addresses this specific requirement and how it simplifies the consumption of data out of your data lake and drives better operational efficiency, right? So the architecture for Splice Machine is as follows, right? So for those who are not familiar with Splice Machine, we are a data platform that combines SQL RDBMS, i.e. OLTP capabilities, with OLAP capabilities and machine learning all in one, right? We run on top of an existing Hadoop-based data lake. We can run on AWS, Azure, Heroku, or on premises, right? And we typically run on your existing cluster. So if you have a Hadoop data lake, we run on top of that. On every node in that data lake, we'll leverage HBase and Spark to drive a combination of these OLTP and OLAP workloads, right? So just to give you sort of an example of what a typical flow would look like. So if you have a BI application, let's say you're using Tableau, you would connect to Splice Machine via our JDBC interface, right? That particular connection would get authorized and authenticated by us. The query would then get processed by one of the nodes. Each of our nodes has a SQL parser, planner, and cost-based optimizer. Depending on the type of query, if it's a transactional query, we'll execute that natively in HBase. If it's an analytic query, we'll run that in Spark. So this determination is automatically made by the engine. We do not have multiple copies of the data. So the same copy of data resides in HDFS and is used by HBase or Spark. And then we return results to the customer's query depending on this particular access path, right? And of course, this is a distributed execution across your cluster, right? And then we also have the ability to have tiered storage. So this particular query can run on low latency data stores like HDFS that is locally in that cluster, or it could be sort of a remote external table that could be sitting on S3 or some other type of block storage, right? So that's the architecture. Now there are various mechanisms for accessing data in Splice Machine. We have bulk import and export API. We have machine learning APIs. We also have a native Spark data source. So for data scientists, there are mechanisms by which they can access the data directly, right? But this architecture dramatically reduce complexity, right? So if you are coming from a cloud world where you're using AWS or Azure, you would realize that there are different sort of database technologies or data platforms, some specialized for OLTP, some specialized for machine learning, that you would have to put them together. You'd have to move data back and forth between them. You'd have to duct tape them together, right? Similarly, if you're coming from a background where you have a Hadoop cluster or you have familiarity with that, very similar sort of experience, right? So you'll have to take things like HDFS, Hive, Impala, Spark, HBase, Kafka, and you'll have to duct tape them together to drive this sort of seamless consumption, right? With Splice Machine, we can simplify that, right? We can run multiple workloads in a single data lake environment without having to replicate data. So the primary benefit is you can get this value without having to invest in a lot of engineers, right? So you don't need multiple infrastructure engineers or platform engineers. Your application developers and DBAs can run this platform. Your speed to market is dramatically improved, predominantly because our environment understands and runs SQL. So your existing developers and DBAs can use this without a lot of training, right? So those are some of the key benefits of our solution. And what is really unique about this approach, right, is as I've been saying, it's about time to market, right? So you can get to a data lake solution very quickly. Your existing personnel who have knowledge in databases and who have knowledge in SQL can run the system without having to go through a lot of retraining. And as a part of our demo, you'll see Ravindra from Diyotta will show you that end-to-end process of how do you set up a data lake and how do you very quickly move data into this type of environment. So some of our customers ask us this question: hey, what's the entry point? How do I get started? So we see customers sort of come to us via three different entry points. One is they may have a database like an Oracle system or a SQL Server system that is not necessarily scaling, and it's costing too much for them to scale that. So they may want to start by either offloading that database or migrating that database. So that may be a good starting point. In other cases, we may have customers who are in the process of building a data lake or have already built a data lake, and they're struggling with some of the challenges that I just described earlier. So that may be an entry point where they sort of bring Splice Machine in, layers on top of their existing data lake, and quickly start delivering value. And then another sort of use case pattern that we see are customers who want to build real-time AI and machine learning solutions, and they want to inject AI into some of their enterprise workflows, right? So again, we provide a very clean architecture and solution for doing things like that. So that's a quick overview of the Splice Machine technology and the use cases. What I wanted to do next is pass the baton to one of our practitioners from a company called Sonoco. So Brent will give us a quick overview of who Sonoco is and what he has been doing in that company.
Good afternoon, everyone. So a little bit about Sonoco, if you've never heard of us. Basically a $5 billion packaging company. You can see we're kind of focused in three main areas of products. And so we've got 300 operations around the globe, manufacturing paper products, plastic products, lot of information sources, lot of several ERP systems, growing in a lot of different areas very quickly. And so the informational needs of the company have really changed over the past few years. So that's kind of what led us down this journey. And if we look at the next slide, we've basically spent about a year going through just a lot of research and trying to understand how to implement a new data platform. There were several things that we needed to be able to deal with in terms of data and informational needs. We needed a much more robust compute and storage platform, just like Krishnan was talking about. We got faster data. We've got more data coming every day from all of these different systems. We also had a need for a single solution to handle transactional and BI workloads. We can't get everything we need out of an ERP system. Sometimes we've got to have other data collection utilities. We also needed it to be able to support real-time events, rich analytics, data science activities, all those things that Krishnan kind of laid out. We really were focused on and challenged with. So we started looking at this, this Hadoop-based environment as a solution point, and came to the understanding pretty quickly that the learning curve was going to be large. We'd never, worked in any of these environments before. So you got this complexity of all the tools, the way things are connected, which tool to use for which purpose, all that kind of stuff. We've got a small IT staff, so it's got to be cost effective. We don't have the capabilities of bringing a lot of people, to support this environment, to make it work, keep it operational. So all those things were challenges that we were focused with. And what we really kind of came to the, conclusion was looking at Splice Machine, looking at Diyotta, and the combination of these two really started to bring a picture of how we can exploit this kind of massively scalable architecture to solve these data problems that we had in terms of ingestion, in terms of storage, in terms of processing, and then, analytics and all that consumption that kind of Krishnan laid out. So that's kind of the journey that we've been on, and really have looking forward to the marriage of these two technologies to be able to kind of really jumpstart us and move us down this road a lot quicker than we would otherwise. So.
Thanks, Brent. That was a quick overview. And as a next thing, I would like to now invite Ravindra from Diyotta to share his experiences. So he would talk a little bit about their technology, their platform, and also show us a live demo.
Sure. Thanks, Krishnan and Brent. Hey, good afternoon, everyone. Can you all see my screen? Can you confirm, Krishnan, if you don't mind?
Yes.
Okay, thank you. Here, so just to give a little bit about agenda, I'm going to go over the Diyotta architecture for a few slides, and then talk about how Diyotta works on Splice Machine, and then I'll jump onto the live demo. Just to give you a little bit of different perspective here, the data lakes are promising, and also it is very complex to implement. As Krishnan had mentioned in his slides, you need to have a right technologies to make it, build these data lakes quickly. And one of the key factor on the data lake success are, the data integration component. If you really look at, in any given organization, the data lakes are one part, and there are different data architectures sitting today. You need to really work, your tool set to other data systems. So, for example, let's say if your organization has a traditional data warehouse system which are built, Oracle, or or you had MPB architectures, you want to really want to get the data migrate to your new initiative which is coming on your Hadoop. So with all these new things are happening, they are really promising, for the business. But at the same time, you have a lot of challenges to bring the data into these, the new initiative for that, right? If you really look at, over the last 10, 15 years, the ETL is the backbone of your data movement or the integration of on your traditional data warehouse systems. But those tools are not anymore work with your Hadoop or the innovative solution like a Splice Machine, and or if you're really bringing you're acquiring a new data which you wanted to put it in the cloud, these tools are not really work well. So with that, organizations are start building their own homegrown solutions for for that specific technology or the use case. End up making complex to maintain those technologies or tools, or it's required to acquire new talent to manage these things. So let's see how Diyotta is going to solve these problems in a overall in our data fabric scenario. Diyotta's unified and modular architecture brings a single enterprise solution to manage the data movement between these many different types of architectures, and help you to build your operationalize data lake to get them business value quickly. So if look at Diyotta has two major components, as the Diyotta controller and agent. Controller and agents are, the agents are basically, tiny softwares can sit on source or near source, which actually brings, extract the data efficiently from the source systems and load into your, your target system. Once the data is loaded, controllers send instructions to the native platform-specific instructions to agent, and which will perform all the transformations underlying platform. So it's a very unique approach we are taking, which allows us to perform data ingestion to your data lake quickly, which I will go over in detail in my coming slides and the demo. Just to give you a very high level, the kind of use cases we are supporting with the Diyotta. So we have a approach where you can just quickly ingest and build data lakes, and we have use cases like migrating the data from different systems to your emerging technologies, or we can build use cases like replication or real-time data ingestion, which is backed by we underneath we use Kafka Connect, and also we have a solution if you want to use in-memory transformations. We do have a Spark solution, and also we do support complex event processing use cases using a Spark. So pretty much if you look at the architecture is very unique and support all these different types of use cases. When it comes to the Splice Machine, the Splice Machine is bringing a transactional nature on top of the HBase, and also it is a very scale-out kind of a solution, which is perfect fit for Diyotta to exploit underneath on the platform. So we can allow the Diyotta brings the solution where you can quickly build your ingestion and the transformation pipelines using Splice Machine. So just to give you some high-level capabilities we wanted to highlight here, with the Diyotta you can efficiently build, test, and deploy data ingestion or the transformation pipelines using drag and drop interface. We do have a wizard type approach where you can quickly build data ingestion pipelines from if you have hundreds of tables sitting in Oracle or any other type of source, you want to bring quickly the data into Splice Machine. We can do with few clicks. And also we use a native bulk approach to extract the data or the load into the Splice Machine. And also we gave optional JDBC approach. And another key thing here is in any data lake initiative, we don't want to have build the model on the data lake upfront. All you can do is you can just build these pipelines, and at the runtime it generates the schema required for Splice Machine, and it loads the data. So basically you don't need to have, you can start with a clean slate, just bring all the data from different source systems to Snowflake. So, and also we expose all the Splice Machine functions and the UDF's Diyotta UI so that users can utilize them and validate at the design time. Support the update, delete, and we have a built-in SVD and upset options. And also we have Spark processing, which natively work with Splice Machine a native context. So, and we support so many endpoints. We can bring the data from all these different endpoints to the Splice Machine. You don't need to really switch different tools for talking to the different systems. We have a one stop for all the you can bring in all the types of data into a Splice Machine or Hadoop. So with that, I'm going to jump onto the demo here. So I have 3 use cases I'm going to explain. The first, I'll show you how quickly you can create data ingestion pipelines from different source systems to the Splice Machine. Then I'll talk about the transformations and then show some Spark data pipelines. So Diyotta is web-based, browser-based, the client modules, where once the controller is up and running, the users can access the modules. So we have 3 kind of module studios where actually you build the pipelines and monitor, scheduler, and we do support. We do have a feature where you can look at the data lineage. And I'm going to showcase, due to the time constraint, I'm going to build in a quick samples, and then I'm going to go over on some pipelines which is already I built. So let me showcase one sample here. In a Diyotta world, we have a data point, a data object. Data points are basically the connections to your source or target systems. Data objects are definition of your, the structure, unstructured, semi-structure or the structured, the definitions, and the data flows where actually, you define your source and targets and the transformations. And with that, I'm going to, create one data flow where you can move the data from Oracle to Splice Machine. So I have a Splice Machine where, I have a schema called, just Oracle, and I don't have any tables in that particular schema to begin with. And also I have in Diyotta, you have a facility where you can actually run the query. So I have that one window is open here. If I look at, I don't have that table sitting there, for example. So let me build the, pipelines quickly. So if I go here on my data flows, there is a feature called data movement wizard. So with that, all I need to select here is, I want to just specify, what type of data flow I'm creating here. So I'll just, keep the name like that, default name. Here I'm going to select here the data point. Again, the data point is, the connection here. So now, let's say if I want to bring the data from Oracle, so let me select the data point, which is already I have it created. So I'm selecting this data point. I have a schema called DL_SRC. I want to bring the data from that particular schema. In the next, where, I wanted to choose what are the tables which I want to bring from that particular, Oracle schema. So I can say import sources. So I'll just ignore the synonyms. I have thousands of synonyms there. So, okay, here I have a sample schema here. I have a 12 table. So let me, just for sample, I can choose, all, or, I can just, for quick thing, and I'll just use the, the 4 tables. And here, what it does is basically it actually get the metadata from Oracle dictionary tables, and, it creates the metadata in Diyotta repository. And then when I go next, and where you need to choose the, okay, you chose the connection where you're getting, I mean, like where you want to get the data from, which is we chose, source as Oracle, and now we have to choose the no, the target, the data point here, which I want to, choose that as a Splice Machine. Here I'm choosing this particular, schema, which right now the schema doesn't have any tables. So in the next step, what it does basically, it is actually creating the metadata for, Splice Machine, and it actually creates metadata, and also it maps the column map between your source and your target, which is the Splice Machine. So, and also you can define, you want to create the table, or you want to, I mean, if it is a, you want to, going for, always you want to trunk and load kind of, approach you're taking, you can actually choose this, or you can actually build a if you want to, parameterize, for incremental approach, you can do that too. So let's say, here, I have these 4 tables, and, then I can just, say next, and I can say save and finish. So basically what it does, it creates the pipelines. So it created, Oracle to Splice Machine pipelines here. So if you really want it, further you want to do advanced things, if you want to build a where class, parameterize, you can do that. If you really look at here, you can actually, whatever the where class which you are putting here, and then whatever the functions which you are going to utilize here, it's all are actually the Oracle functions. You can actually push up to your, in the runtime, all this, the logic push to your Oracle side if you needed that. So otherwise, for now, I just, I created this sample, I'll just run it. So I just ran that. So then, if you go and look at here, this is the monitor module where, I can see the running here. Let me go and let me see here. So this is a 3.1 that I just executed. It just finished in like, less than a second. So this is the sample data which I just looked at. So if you go and look at, the data, if it is loaded, I can just run the, or, you can just, if I go and look at here, the tables are loaded here, or let's see what, maybe the different schema which you loaded. Let me verify that quickly. Okay, I can just, use this, and let me show you this from here. I have this Splice Machine data, and I can just do the, it loaded in the different schema. Let me go to the parent here, which, this is the schema. I can just see the data here. It's loaded. So you don't need to, you can actually open that, in your SQL editor. So this is the data is loaded. So with the few, steps, you could able to, bring the Oracle data to your Splice Machine. You don't have a schema created upfront, and, you actually generated the schema and loaded it with that. So, okay, so once you loaded the data, what do you do with the, the data? So you need to really you need to conform your source data to some other data structures where, the data sciences can utilize, or you can you can have your BI tools to point to the Splice Machine. So for that, we can actually build a transformation pipelines. I'll take an example here. One, I actually already have the one pipeline here. So here I have the data is here in a Splice Machine. So I wanted to, let's in this example, which I'm actually bringing, address is the attributes are coming from different source attributes like, supplier, store, or customer. These are all the different sources has the address. And what I'm doing here is, we actually combining the address records which are coming from these three different attributes. And, I'm basically wanted to have upset kind of, functionality here. If I have the dimension D address, I can actually join with, if there is the incoming address is the new, or, it is already exist in the target. And then based on that, I can just, update or, insert new record. So for that, we can use, we have a different types of, transformations where you can use in Diyotta. So this is a union transformation we are using. This is a joiner. So for example, while you're doing joiner, so here you can define what type of join you're using. You can use a left outer join here. I'm just just a simple scenario which I'm creating just to give you some understanding here. The functions what we have here, the functions what you see here, it's all Splice Machine functions. So we bring those functions to the UIs, and we can so that users can use it and can validate. Once you code it, you can validate. Once the function is validated, that will run Splice Missions. At the same time, you can also view the script, what kind of script it is generating underneath, which pushes down to your Splice Mission. It does that. And then also very new with the new release, what we call it as interactive design. While you are defining it, you can actually see the data, what data it contains. You can actually look at the data, while you are building, your transformations. So, and also here I wanted to show. So one thing here, if you go here on the target side, we support different types of options here. You can do the insert, update, upset, delete, or SCD. These are all built-in functions. If you select that SCD, we'll ask you to configure that, what type of SCD unique key, or SCD keys, or the SCD start or current indicator. And based on the industry standards, we came up with this approach where user just configure this, and we take care of the implementation of the slowly changing dimension for you. You don't need to, in a general way, it's required a lot of effort to build the SCD type of implementation, but we actually build it for you. So with that, I'm going to jump on to the one example which I'm going to show you on the Spark. So let's say if I have some Spark pipelines are here. So if I look at here, we have so whatever you have done using a Splice Machine, the Splice Machine, it actually diverts your query or workload to based on the type of query. It determines whether you want it executes to the Spark or HBase. So that is something which Diyotta, through Diyotta you can exploit. At the same time, we are bringing the Spark approach where if you really want to build a Spark solution where you can have the Splice Machine natively work, bring the data and creating the data frames on the fly, and you can use the same Spark functions like the way what I explained in the Splice Machine. You can actually use the functions here. These are all functions which are actually supported by the Spark. So we bring those Spark functions to the user where you can use it. We have several UDFs, a lot of functions. You can use that. And once the data is, every unit, we actually create a data frames, and from there you can just take to the further destination using in this case we use the native Splice Machine context to push the data into the Splice Machine. So with that, I'm going to stop here for for question and answer. Back to you, Krishna.
Thank you, Ravi. So So I think what we, just to quickly summarize, right? So we were able to demonstrate really quickly how you can accelerate your time to market for a data lake type initiative with the combination of what Diyotta brings to the table and the transactional capability and the machine learning mixed workload capability that Splice Machine brings to the table. You can offload data from existing RDBMSs like Oracle or SQL Server, bring that data into Splice Machine. You saw that Ravish demonstrated an example where he was able to bring a few tables very quickly. And by just automating that process, you can seamlessly bring data in, manage updates, set up complex transformations, and then open it up for consumption across different channels, right? Whether you are using BI tools, you're using applications that want to consume it in a transactional manner, or analytic workloads. So all of that makes it extremely possible. And then the feedback that you heard from Brent was how he was able to sort of put together this type of an architecture and then realize that that value very quickly, right? So hope this was helpful. I did want to make sure that we are available to answer any questions that the attendees have. So this would be a good time if you want to put your questions in the chat window or in the Q&A window. We'll be happy to answer that. There's a couple of questions that have come up that I wanted to make sure I address. The first one was around if organizations did not have existing data lakes or they didn't have a Hadoop environment, how easy or how fast can they set something up like this with Splice Machine? So one thing I did want to reiterate is that Splice Machine is available as a service on AWS, Azure, and now Heroku. So if you want to quickly provision an environment without, even if you didn't have the your infrastructure or machines in your environment, you can do that. And when you set up a cluster through our service, it comes with all the compute and storage associated with that. And also Diyotta can still be used as a mechanism to bring data into Splice Machine, either across your cloud environments or between your on-prem and the Splice Machine cloud environment. So there are ways by which we can definitely get you started, even if you didn't have the right amount of infrastructure in your environment. Let me see if there are any other questions. I think there was a question, and I don't see Splice Machine in the in Azure. I think we can send you a link. So that's an offline request on our side, so we can take care of that. Okay, so there are no other questions. So so on behalf of Ravindra and Brent, I would like to thank you all once again for attending our webinar. You do have our contact information that we have listed here on the slide. So feel free to send us any questions you may have. And if you had registered for this webinar, you will get an automated email with a link to this recording and also the slides. So feel free to send us, follow up with any additional questions. And we'll also send you some additional content in terms of demos and things of that nature that you can benefit from. All right. Thank you very much.